Good afternoon. My name is Emmanuel Luis Villanueva, and I am a part of Group 1 who aims to develop a new, or rather an alternative writing solution for pens. We aim to propose the conversion of vehicle gas emission into a usable ink with the use of filtration method. So, to introduce the topic, in today's generation, the pollution is very rampant, brought by the progress of industrialization and modernization. Vehicles run on diesel and gasoline, which in turn creates carbon upon burning in order for cars to accelerate. So basically, carbon is the byproduct of burning the fuel of motors or vehicles. And what we aim to do is use that carbon that comes from the car or the vehicles and use it as an ink, as a substitute for chemical ink. So the problem is not existent due to the scarcity of material. This is pertaining to the school supplies, but rather being smart about the pollution that we create. Carbon can be smartly used as an ink or lead component of the pencil, for they are discarded and byproducts of vehicular gas combustion. So basically, the carbon that the car creates or produces has no use, and what we aim to do is to maximize the use of that pollution or byproduct and use it into something else, such as a pen or the lead of a pencil. So the statement of the problem says that ink and pencil have primarily been one of the main components when it comes to school supplies, enabling the user to transcribe thoughts that they could into a written format, which can help teach others as well. The problem is that the availability of the writing materials is limited through chemical production. By using pollutants that we already cause in the air, we aim to reduce the pollution that is emitted by vehicular gas combustion and use them as a main component that can supplement an apparatus for writing. So like we have mentioned earlier, we aim to use the pollution that we create with vehicles into a writing material. So our objective is to create an alternative ink supply that can be used by conventional pens, to contribute to the reduction of carbon footprint, and lastly, to be able to develop a renewable source of school supplies. Our scope and limitation states that the proposed solution would only work on diesel and gas-based engines of vehicles and would only be able to absorb the carbon that they emit through the use of a physical device that is to be attached onto the exhaust of the vehicle. This would not be able to collect carbon in the air alone. It will also not work with petroleum gas that is used on some modified cars, such as taxis who uses a liquefied petroleum gas tank as their fuel source. So, like we've mentioned earlier, this would strictly work only with diesel and gas based engines. Vehicles that uses LPG produces a different fuel or byproduct which we cannot use in order to create the black carbon that we need as a writing component.
My name is Isauro Angelo Robles and I am assigned for the RRL. Our first RRL is the silicon ink high efficiency solar cells. This RRL concentrates in the Innovalite, has developed a proprietary low energy, low cost synthesis approach yielding abundant quantities of high purity silicon nanoparticles. The silicon nanoparticles are formed through homogeneous nucleus form an expensive and abundant silicon precursor. High precursor is largely decoupled from the polysilicon and silicon wafer supply chain and any associated price volatility. Solar cells are yet visible in our eyes. So in this approach, they use a microscope to have a clear vision of the solar cells and transform it into a silicon ink. Next is the all screen printed mass produced silicon ink selective emitter solar cells. In this article, it talks about the cell fabrication process at Innovalite was completed on industrial scale equipment using commercially available silicon wafers, it has a standard homogeneous emitter solar cells were used for comparison. On the following conventional processing steps, a reference screen printed solar cells were made. Like in the first RRL, this RRL uses solar cells to produce silicon ink and to be used as a screen printed mask in a selective emitter. And the other 3 RRL is the study of screen printability of UV soy ink on plastics. They use plastics to transform into a UV soy ink. Then the fourth RRL is the novel digital carpet printing using acid ink. And last one is the rewritable hydrogel coatings using water as the ink. Used or unused water can be converted into ink. So the unused water will be used again, but as a ink, not a garbage or waste material. That's all for the RRL. Thank you.
My name is John Gabriel Oebora, discussing the methodology of this research paper. According to the study, over the last 150 years of mankind has been dependent on burning fossil fuels directly or indirectly for their energy needs. Soot is the major byproduct of the burning of fossil fuels. Research has shown that many premature deaths are directly related to soot in the environment. Particle exposure leads to around 20,000 premature deaths in America each year. Data also shows that soot annually causes almost 300,000 asthma attacks and 2 million lost work days due to respiratory problems. The conceptual framework. From here, you can see the input, process, and output. For the input, we capture gas emissions from exhaust tips, then process it by filter and purifying the captured gas emissions, resulting in the purified gas emissions are transformed to ink. The unit automatically turns on when an engine is activated and gases start flowing through the exhaust. This activates the flow and thermosensor, which in turn engages a mechatronic capture system. All fine particulate matter is then captured within the walls of the unit. However, gases are allowed to pass through, leaving the engine unaffected. When the lights on the exterior of the unit turn from blue to red, the catchment is full. From here, the captured pollution is taken through a process that removes trace heavy metals and carcinogens. The purified soot goes through several industrial processes to make different types of inks and paints.
Hello everyone, I am Christine Dominic Cabalar and I'm here to discuss about the conclusion of this design project. So based on the articles we gathered, it will be a lesson for controlling air pollution environment and the health of the people who used to commute, especially in Manila. When we are using this kind of experiment or design experiment, the air pollution around the globe will be lessened. It's very useful to our life cycle to protect from diseases. So the other conclusions here were these are the most creative pollution capturing technologies to save our planet. And air ink is a cheaper alternative to make inks and paints, and it is an eco-friendly and safe. So our recommendation for this project is, since the ink is usually black in color, we recommend that the air ink should have a different kinds of color other than black. So in this kind of design experiment or design project, the more ink in the page, the less pollution in our lungs. And that's all. Thank you so much.